So today we're going to combine two things that we already know. We know how to solve inequalities, and we also know how to graph equations. So we're going to combine them, and we're going to learn how to graph. We're going to graph equations that are actually inequalities. So we're going to graph this inequality on the coordinate plane. So I have y is greater than or equal to x minus 5. If this was y equals x minus 5, that would be pretty easy to graph, right? My x-intercept is -5. I have a slope of +1, and my line just goes like this. And it's really not a super challenging one, right? And I can take my line over here and draw a line, and all of the points on this line make that equation true. So if I substitute in the point 5, 0, it makes that point true, right? It makes that equation true. Well, there's going to be a few more points that are going to make this equation true, because not only do I have the points that are equal to, I also have the points that are greater than. So how do I deal with this greater than sign? Well, I'm going to do a test point, and I'm going to see if the point is greater than. So if, let's say I choose the point 0, 0. I like choosing 0, 0 because the math becomes very easy, right? So if I have 0 for y, 0 is greater than or equal to 0 minus 5. So we're going to simplify this, and 0 is greater than or equal to -5. Is 0 greater than or equal to -5? Yes. So the point 0, 0 is going to be part of my solution set. What about another random point over here? What about the point 4, -6? Okay, so let's substitute those in. So -6 is greater than or equal to 4 minus 5. So this one worked. -6 is greater than or equal to -1. Well, is -6 greater than or equal to -1? No. So does this work? No. So is that a solution? No. And actually, all you have to test is one point. And if one point works, then you know that everything on this side of the line works. So you can shade it in. You can shade it in fancy. You can shade it in however you want. Or you can be scribbly about it and shade it in like this. It doesn't even matter, okay? I don't care how you shade it in, but you just need to show me, hey, everybody, everything over here is a solution for this inequality, and nothing over here is, and the line is. Now, what if the line isn't? Here we had y is greater than or equal to, so I could do the equal sign. But on this side, I just have y is less than. Y is less than 2x plus 4. So what do I do with that line? Well, first, we've got to figure out where the line is going to be. So this is still going to be our line of separation. Half of this plane is going to be true, and the other half is not going to be true for this, this inequality. So I'm still going to find my points the exact same way that I found my points up here. Conveniently, this is in point slope form. I know that the y-intercept is at 4. And the slope is 2/1, and it's positive. So I'm going up here, and I'm going down here, right? So this is my line, or the points that are going to be on my line. But unlike the last one, these points actually don't hold true for this equation. These are the points where y is equal to 2x plus 4. Y is not equal to 2x plus 4. Y is less than 2x plus 4. So I'm not going to be able to have a solid line here showing that it's equal. So what I do is I still need that boundary. So I make a dotted line. And this dotted line is basically the way of saying, hey, there's a boundary here, but the points that are on this line are actually not true for this inequality. Okay, so I've got my my line here. I couldn't actually draw the big line with my fancy digital tricks. I just had to draw a little dotted line by hand, which is fine. can draw a dotted line by hand. But now I still need the shading because it's still y is less than 2x plus 4, right? So I'm going to pick a random point. Once again, I'm going to pick the point 0, 0 because it's easy and I like that. So I'm going to choose a point 0, 0 and let's test it. So y is 0. 0 is less than 2 times 0 plus 4. Let's simplify this. 0 is less than 4. Is 0 less than 4? Yes. So does the point 0, 0 still satisfy this inequality? Yes. Should we try one up here just for giggles, just to see? Let's try -3, 3 and just see if it works. All right, so 3 is less than 2 times -3 plus 4. All right, so let's do some simplification. 3 is less than -6 plus 4. 3 is less than -2. Is 3 less than -2? No. So are the points on this side of the graph part of this inequality? No. Are they solutions? No. Only the points on this side of the line are solutions. So we're going to fill this in however we fill this in, however artistically or not artistically you want to do it. Oh, I crossed my path. I didn't want to cross my path. But however you choose to fill in your side of the graph is how you do it. Does it need to be complete and total coverage? No. But do I need to be able to tell what you're doing? Yes. So let's try another one. We have y minus x is greater than 1. So it's not equal to. So I'm not going to have a solid line. I'm going to have a dotted line. I can tell that right off the start. But I'm not in point slope form this time. So I'm going to get myself into point slope form because I really like graphing things in point slope form. Or in slope intercept form, excuse me. So y is greater than x plus 1. So my y-intercept is 1. My slope is 1. And it goes up like this. This is why I love slope-intercept form so much because it makes my life so easy. I'm going to make a dotted line all the way up, all the way down, so that I know the boundaries of this inequality. Okay, so there's my boundary. And so it doesn't include the boundary though, because it's not less than or equal to, or greater than or equal to, it's just greater than. So we're going to erase that. So we're going to do a test point. Okay, let's do a test point. And my test point is going to be 0, 0 again. So, and I don't even have, I can go back to the original equation, or I can go back to this one. So 0 is greater than 1. Is 0 greater than 1? No. So I know that 0, 0 is not part of the equation or part of the inequality. It's not a solution, so everything on the not 0, 0 side is. Let's do one that doesn't have a y. Do we need to have a y? No. We can just solve for x here. So let's subtract 4 from both sides. 7 minus 4 is 3. So 3 is less than or equal to 3x. X is greater than or equal to 1. So it's going to be the solution of all points where x, well, let's graph where x is equal to 1. It's going to be this line right here. And then I need where x is greater than 1. Well, this one is actually easy. I don't have to do too many test points. It's this entire side of the graph where x is greater than 1. So even with vertical and horizontal lines, it can still work. Good luck. Let me know if you have any questions, and I will talk to you next time.